Okay, now we're going to talk about different types of switches. Well, not even switches. We're going to talk about AC, permanent magnet sensors, and the digital sensors, Hall effect. Talking about different types. It could be in switches, themistors, rheostats, potentiometers, permanent magnet generators, digital, oxygen sensor, vibration, and feedback sensors. Now here's the simplest type of sensor. Here's the simplest type of digital signal. It's a switch. Off on. A digital signal can be high and low. A switch is high and low. When it's off, 12 volts, on, near zero. Depending on the circuit, it could be other way around. But that's the simplest type of digital signal. An off-on switch. It could be a simple switch, a multi-purpose switch, a resistant multi-tech switch. You can see here are switches. If I put a voltmeter here, or here, in the present position, I see a high voltage. As soon as I engage it, it goes low, high, low, like a digital signal, high, low. Now, let me see the next one. Now this one's an AC signal. Unlike a digital signal, the AC signal requires no reference voltage. The digital signal requires a reference voltage to work. An AC signal is permanent magnet type sensors. It goes from positive to negative. It produces an AC voltage. It requires no reference voltage. Now the middle here, you can't see it right here. That's a zero line, cross point, right here. So I would go positive, negative. An AC signal go above and below the zero. A digital signal always stays above zero. A zero threshold. The AC signal above and below it. As you can see here, this is an analog AC signal. It changes proportional to the signal. As something rotates, you can see it goes up, then it falls back down. It goes up and falls back down. It goes negative, positive, negative, positive. It changes with the rotation of the reluctor. So AC signal, analog AC signal, changes in proportional with whatever the signal is controlled by. Here's another way. Here's another form of it. It's also an AC signal. You can see the cross threshold is here. This is zero, positive, negative. And here are some faults. They can be reduced by a faulty AC signal or wiring or magnet. Let's look at one low. Look at this. Can you see this? Can't see it. I don't know if you can see that or not, but can you see my magnet here? You can see my magnet here. I don't know if you can see that or not, but the second one, low or no signal or low rotating speed, rotating speeds. A weak magnet or a large sensor gap can cause that. Number one, no signal at all. Faulty sensor, the reluctor wheel or trigger. Open circuit can cause that. Now, let me go weak magnet. Let me show you something here. You see this here? The gap they're talking about that causes a poor input from the AC generator. These are the teeth around this reluctor wheel. If it cracks or one is missing, it causes a erratic signal. If this magnet here is weak, it produces a low signal also. That's basically what they're talking about. Now the next one is a digital signal. A digital signal is a Hall effect. Magneto-resistance are optical sensors. They on-off signals. And on this picture here, I want to show you something here. You see right here, it's a 5-volt supply to this cam sensor. 5 volts, ground, and input to the PCM. This signal will produce a digital signal, but as you can see, it needs 5 volts for it to work. It needs a reference voltage. It could be 5, not seeing at 9, 12. It depends on the manufacturer, but a digital signal requires a reference voltage. And a digital signal is basically an on-off switch, high-low, high-low, high-low. But unlike the AC signal, here's 0. It stays above the 0 line. This right here, this line down here is 0. A digital signal has to stay above this. So I'm going to see high, low, high, low. So let me see what this, where is it? It's 2 volts per division, as we learned in the previous slides in the electrical section. Yeah, this is 0, it's 2, 4, 6. So right here is about 5. So it's 5, 0, 5, 0, high, low, like a switch. It's on off. Now the only thing about this digital signal, it can be an input. See, I'm pointing at it. You see the cam sensor? This cam sensor is an input to the computer. It's a digital input into the computer to tell the computer the position of number 1 cylinder. It could be a crank sensor. Digital input to the computer to tell the computer RPM from the crankshaft. And in some cases, that same digital signal, we know it could be an input. Guess what? It can also be an output to this coil. You can actually literally have a output from, here's that, let me see here. Here's voltage feeding the coil here. Here's control right here. The PCM can provide an output, a digital output from the coil driver to the coil to fire the ignition circuit. So basically I'm saying here, a digital signal will be an input or an output. It depends how the manufacturer chooses to use it. This is a cam crank sensor. Here's a Hall effect. A Hall effect is a this distributor produces a Hall effect signal into either a module or computer to fire the ignition circuit. So this distributor here produces a Hall effect signal, which is a digital signal either to a module, ICM, or the computer to fire the ignition, which looks something like this. See this? These are digital signals. High, low. Now this is from a cam sensor. High, low. Crank sensor, high, low. So now we've seen so far that digital signal will be an input from a sensor or distributor, or an output to control a module or some other type of component. So it could be either or. Magneto sensor produces an AC signal. All right, it's like a crank sensor. That's an input into the computer to the position of the crank or cam. It's a magneto sensor. It's a permanent magnet sensor, AC. So to recap on this, the digital signal will be on-off circuit, like you see here. It could be an on-off, like you see here. It could be either an input or an output device. It's either high or low. And oh, I forgot to say, it's a square wave. All right, this is a square wave. Hall effect signal here, all high low, it's a square wave also. A digital signal produces a square wave. Unlike the AC signal produces an analog AC signal, it's like almost like a sawtooth wave. Let's see, what else on this one? My AC signal here varies in proportion to other signals that's using it. So it's a varying voltage. So my AC signal is a varying voltage. And they also call it analog AC voltage. That could also be an input into the computer, AC. A cam or crank sensor also, but not an output though. Computers don't read AC signal. This AC signal is going to be converted to a digital signal. That's why it's not an output, but it could be an input until it's converted over to a digital signal. So my analog AC voltage can also be, I forgot this right here, it can also be a speed sensor too, wheel speed sensor, which is a permanent magnet generator also. So this magneto-resistant type sensor could be a cam, crank, or speed sensor, wheel speed sensor, which produces a permanent magnet, which is actually a permanent magnet generator. Let me see. I think I got all of it. Is there anything else? Oh yeah, on the simplest on-off digital signal was this one, a switch. All right, that's a simplest on-off signal, digital signal. It's a switch. Analog. Do you remember the analogs? Let me see. Analog signal voltage could be. Analog signal voltage. Analog AC voltage, I should say. Let me see, gotta find analog AC voltage. Analog, remember, it's permanent magnet, analog AC voltage. Now you can also, I didn't mention this, but you can also have an analog DC voltage too, which is a throttle position sensor. That produces an analog DC signal. I'll probably show that one later because I don't have a slide on that one. Remember, this is a square wave on-off digital signal, which it looks like something like this one also. A digital signal will be an input or an output. So I can have an input from a camera cranking to the computer. I also going to have an output that controls the firing of the coil, like here. I can have a digital signal here firing this ignition coil. Oh, here's an analog. Guess what? Analog DC voltage. We see the analog AC voltage. It's an analog DC voltage. It's not going below 0. Cause my midpoint here is 500 millivolts. At the bottom is 0. But it's an analog DC voltage, meaning it's a varying voltage. Analog DC. When you hear the term analog DC voltage, means it's a varying. It's a varying voltage. It varies. Let me see if I can say this. An analog DC voltage is proportionally changes with the position of something. In this case, oxygen. TPS, the throttle position. A vane sensor, the vane door. So it changes as an analog voltage that changes position in proportion to another position of something, an operation of something. Like the most common thing is the TPS voltage. All right, that's an analog DC voltage. So we got analog DC, analog AC, digital on off. That's about it. And again, sensor The sensor is an input also, not output. That's an input. Well, I hope that wasn't too confusing. If it was, hit me up in class. Let's go to the next one.